Welcome back to Best Academy TV. In this video, we're gonna focus on electric field, that is case when distance is given. So the previous video we consider when force is given. So we solved some questions there. So in this particular video, we want to focus on when distance is given. Okay, the expression of electric field when distance is given is mathematically expressed as E equal to KQ over R square. So whenever you are asked to find electric field and distance is given, the formula to use is this formula here. The K here is a constant and the value for this K here is 9 times 10 to the power of 9. Unit is Newton meter square per coulomb square. Please don't forget. While this arrow here represents distance, but if proton or electron is given, the arrow here represents radius. Please don't forget. So class, let's prove the formula for electric field when distance is given. That is, let's prove this here to understand this formula perfectly here. Okay, now we can prove this particular formula from the fundamental formula for electric field. Now, what is the fundamental formula for electric field here? So the fundamental formula we know for electric field is electric field E is equal to force over Q. Please don't forget. Okay, we can call this particular formula here equation 1. So relating the force with distance, so the only parameter that can be related to distance is this force here. And we all know that this force here is electric force, sorry. We can either call it electric force or we can call it electrostatic force. And the formula for electric force when two charges is given, or when charge is given to us as F is equal to class KQ small letter q over R square. The capital letter Q is standing as Q1. The small letter q is standing as Q2. Please take note, okay? So I will call this particular equation here equation 2. Okay, now let's impute equation 2 into equation 1. Impute equation 2 into equation 1. Impute equation 2 into equation 1. When you do that, let's replace this here. When you do that, E will be equal to KQ small letter q over R square over Q. So let's simplify this here. To simplify this here, our E, which represents electric field here, will be equal to, class, please take this K, capital letter Q, small letter q over R square is together. Please take note of that. So we express this mathematically as KQ small letter q over R square divide, that is the division here is this here, please don't forget, divide by Q over 1. Let's apply BODMAS here. When you apply BODMAS here, our E will be equal to KQ small letter q over R square times, we are going to invert the right hand part, so this will be 1 over Q. So class, this Q, small letter q, will cancel this small letter q. I'll be left with KQ over R square. So this is how we derived the formula for electric field when distance is given. Okay, so let's consider a question here to perfect this particular formula. Please write question 1. But let's consider this question here, class. And I said consider Consider an electron in a conducting sphere of radius r equal to 5.2 times 10 to the power minus 11 meters. What is the E field due to the electron of hydrogen atom at nucleus of the atom? So we're asked to find the E field, that is the electric field due to the electron. So class, the electron is mentioned here, meaning that whenever you see charge, the charge will automatically change to E negative. Don't forget that, okay? So let's solve this here. Solution. The formula for electric field when distance is given is E is equal to KQ over R square. Please remember that. So let's impute the values here. This is E is equal to K is a constant value. Remember this, that K is equal to 9 times 10 to the power of 9 Newton meter square per coulomb square. So representing this here, this will be 9 times 10 to the power of 9 times this Q here will automatically change to E. This our Q here will automatically change to E negative. And the E negative here is said to be minus 1.6 times 10 to the power of minus 19. Please don't forget that whenever these two words here are mentioned, either electron or proton, it means that the charge will automatically change to E. So it depends on the one mentioned. It depends on what is mentioned there. If electron is mentioned, it means that the E will be E negative. If proton is mentioned, it means that the E will be E positive. Don't forget that, okay? So let's replace the distance here or the radius here since it's electron. So representing the radius here, this is going to be 5.2 times 10 raised to the power of minus 11 all square. So class, let's multiply. This will be equal to class E will be equal to 9 times minus 1.6 will give us minus 14.4 times 10 raised to the power. Let's operate on the powers. This is going to be 9 minus 19 over 5.2 times 10 raised to the power minus 11 all square. Simply means that this square here is affecting this here. Please take note. So when you do that, I will have this to be 27.04 times from the law of indices, using power law, this power here, we multiply this power here, that is minus 11 times 2 will give us 10 raised to the power of minus 22. Please take note. So let's divide the number here, the number at numerator will divide the number at denominator. So our E here will equal to minus 14.4 divided by 27.04 will give us minus 0.5325 times 10. Remember from the law of indices here, 9 minus 19 will give us 10, minus 10, sorry. This will give us minus 10. Taking minus 22 from denominator, sorry, to numerator, this will be plus 22. So I will have this to be minus 0.5325 times 10 raised to the power of minus 10 plus 22 give us plus 12. That is 12. Okay. So let's represent everything here in standard form. From here to here in standard form, I will have this to be the value of our E, which represent electric field, will be equal to minus 5.325 times 10 raised to the power of minus 1 from here times the left power here, which is 10 raised to the power of 12. So I will have this to be from the law of indices, this is 10, this is 10, we take only 1, minus 5.325 times 10 raised to the power of 11 in Newton per coulombs. Please don't forget that this is our answer here. All right. So this is how we solve questions for electric field when distance is given to us. Please take note. Okay. Okay, let's take the concept of electric field lines. Please write concept of electric field lines. So the first concept of electric field line here is, please write, the lines do not touch one another. The lines do not touch one another. Okay. So it means that the line of electric field are parallel. Please take note. So if I have something like this, this side is something like this. Um, I have something like this. I can create this. Okay. This it looks like plus Q. Okay. This lines here does not touch themselves. Okay. So that is what it means here. So let's take the next one here. The next one said the lines are continuous. Okay, the line continuous. The lines are continuous. Two, the lines are continuous. Okay, three, they start on positive charge and end on the negative charge. I will explain that. They start, so this is what it means here. This is positive charge. So the line always move from positive charge and end at negative charge. So it begins, the line will always begin from positive charge and end at negative charge. Please take note of that. So the last part here, please write, the electric field vector E is tangent to the lines of force at each end. The electric field vector E is tangent to the lines of force at each point.